Hey everybody, this is Larry. This is June 2nd here in New York City. I'm going to do a Leetcode algorithm problem that I haven't done yet. I've been doing them in backward order just for whatever reason. I don't know, just trying something new. But today we have 3088, mixed string anti-palindrome. It's a hard problem. So we have some challenge ahead of us today. Hopefully it'll be okay and reasonable because I do want to sleep and maybe eat something. Hope everyone has have a great weekend so far. But yeah, we call a string s of even length n and n time palindrome if for each index the I is not equal to s sub I. Okay. Oh, so just for each index is different. Wait, what? You could do swaps. And we have to return the lexicographically smallest one. Well, I mean, I think, okay, so my first impression is that, well, you can swap all of them, so in a way, it's fine. But then the second thing is that because you want to do the lexicographically smallest, that is actually the harder, I wouldn't say it's the harder problem, but it's definitely something that you have to keep in mind, because I think that makes it that is the important part of the problem, rather, right? I mean, because otherwise you can basically just put anything in any order and that'll be fine, right? Um, Double check real quick. I think the first idea is that we can just sort the strings, right? And then so if you sort the string, then there's only going to be one edge case, right? Because by definition, and if any character appears more than half the string in an obvious way, does it always have to be even number? It is actually. Okay, but yeah, so if any character appears in more than half the string, by pigeonhole it doesn't matter, right? Then it just return -1. Otherwise, if you sort the string, and there are a couple of ways to do it, then there's only one case, right? Then that means that if the case is that if I mean, not an A, maybe like you have a C, you have 6 C's, you have AAA, and you have DDD. But in this case, this would be a palindrome. This is not an anti-palindrome, but you just have to move things around. So there's really, and then so there are only two cases, right? One, we just basically, I'm trying to think whether this is true. Or maybe there's only one case, but basically we take the most frequent thing. Like, I feel like this is like a case analysis problem, really, on the most popular character. But you still have to be a little bit careful on the second most character, maybe. Because for example, in this case, let's say we have AA. Well, you can't do this even if the CC is correct, right? Oh, wait, I guess we need another one. Because then in this case, it's not enough that you care only about the C's. You also have to care about the A's, right? In some combination. I mean, maybe this is not a perfect example. And I think the challenge about this problem, and maybe during a contest especially, but now I'm slowing it down to think it through more deliberately. The challenging thing is programming in a way that yields the least number of edge cases as possible. And I'm trying to think about a more general arcing thing, because everything we talked about, I think, to be honest, or my inclination is that there is a way that you could solve this with like 10 if statements or something like this, But yeah, all right. So the first one we'll handle the -1 case, right? So if max of collections.counter s.values is, let's say n is equal to length of s. If this is greater than n, then we just return -1, right? And I'm just being really lazy. We probably need this anyway, so let's just put it out here. Right? And then now I'm trying to think of a case where, yeah, because I think there's so many edge cases, right? Because there is even like a case where C might not need to be half of it, but let's say you have a lot of random stuff, right? And then like something like this, G H I J K L M or whatever, right? Here, if K is in the middle, then you can't have it in the middle. So then you have to, the lexicographically smallest one would be like to move some of these letters here to go to like right after K. So the lexicographically smallest one is a tricky case for sure. And the way that I would want to handle the lexicographically smallest is by intuition. I mean, I think they're like, if you only need one answer, they're actually like, I think it's not that hard. It's not that difficult. Like I said, you could sort and then maybe jiggle a few things around. And I think, yeah, you could jiggle a few things around and get it right. But I think the lexicographically smallest one is thing. And one idea that I would have is to figure out a way to construct the solution one string or one character at a time. Right? Like we brute force, can the answer be an A? Can the answer be a B every time? So the first character, can it be an A? It can be an A if, well, I mean, obviously if we have A's left, but also okay, I think I buy that. Wait, am I even right on this case? Right, because actually I think I'm wrong on this case. I had this, right, say, because I don't even think that was the right answer. And which is why this other greedy thing is, because I think the right answer is actually moving some of these K's. I don't know, I mean, this is off the head, to the back, right? So then now this K matches with an H or something like this. I'm maybe off by 1 or whatever, but you get the idea. So this would be shorter than the other idea of moving D to the back. So, okay. So then the one character at a time idea would be to figure out a quick way that we have enough space for all these. And we have enough space for all of these. What is the relationship that we can think? Right? Like how do I how do I define this relationship in a good way? Especially the tough part is that like at half of them they mirror, right? So I can't throw stuff in the back as easily, and that's in a reverse greedy way. But I think I am trying to think through this idea of, okay, let's say we have A. If we can we use an A here, right? And what is the relation? Like, how do I know that, for example, once we're here, we have to use a K at this mark? Basically, there is okay. So at one character at a time, we create basically one free space at the end for anything. Anything not an A, but in a greedy kind of way, that would never be an A. Right? And then past the second half, we'll just fit it, but we have to make sure that the math works. But how do we check that? So let's say we get to this K, we have 7 space for anything not K. I think this is a very hard problem. I think the idea that I don't know, one of the ideas that I have is just tracking the max element or the most frequent element, but I don't know that that's enough. I can't prove that is enough. Like, what if we have another G, right, or something like this? Then maybe we need. Okay, let's say it's not even half. Then you just push to the thing. Okay, so only with. Is caring about just the most frequent object enough? Because then in that case we just break it to I'm trying to prove in my head that only caring about the most frequent object is enough. And it's always possible because you can just break it in half, right? It just depends on where do you put the halves. And it's not always half even, right? I mean, half is a proof that you can do it, but it's not always the most optimal, right? Because there could be a case where there was if this is early enough, we have 6 Ks in the beginning or whatever, and then 2 Ks at the end, and that may be the lexicographically smallest one, right? And well, I guess once we get to the max, we can just throw it all out. So it only matters what the count is before the max, because for the max we want to get it as early as possible, or not as early as possible, but if it is possible to get it early, then we would just do it. All right, I have some ideas, but I think it is time to start implementing. I would also say that if I was in the contest, I would definitely YOLO a little bit earlier, but it is what it is. So yeah. But yeah, let's just say okay, and then now maybe for C and F dot keys, if F dot then we break max C for character. I don't know. Okay, so then now we brute force is A possible, and so forth, right? So we have to do. Okay, so we try for C in was it strings dot lowercase ASCII. I always forget how this is. Yeah, let's just print it out. Mostly because I always forget whether this is it's either string or strings. ASCII lowercase, basically. I know there's some combination of this, but I always forget. Okay, fine. right? So then now here, if f of c is greater than 0, then we can append this maybe. The idea that I want to do is that I guess it doesn't matter. I guess because if the character is less than half, then it doesn't matter when, because you can, in the other way, you can also push whatever. I got it wrong, but you can also push all the case to the other side as well. And in this case, the case are actually a little bit weird, because here you want it to be after the first two spaces, so it's actually here and not all the way at the end. Okay, so maybe the greedy works, and I just kind of overthought a little bit. Yeah, and then we break. Yeah, I guess so. I guess it really doesn't matter. If this is the case, and answer of I, or n minus I minus 1, is not C. But this has to be, well, I have to put it before. Is less than n. This looks very awkward. So plus I on both sides. Minus n on both sides, right? Wait, what did I have? I plus 1 plus I minus n that doesn't make sense. What I want is that it's that, yeah, this number is greater than is less than length of answer, not n. That's why I got a little bit confused. This is actually I. Yeah, this is I. That's why. So then this is 2 times I, because which makes sense, because I'm trying to do it as like less than half, right? So yeah, okay, fine. Okay, and then we just return. Yeah, maybe I made this more complicated. I thought there'll be more cases, but still out of range. Oops, this one is fine. Did I mess this up? This is going to be length of answer, right? Oh. That's because this never gets called as a result. I mean, this is the case if it is whatever, but we need this. Okay, if this is so if this is the case, or I'm just being dumb. It's basically we only check for this if it's greater than half, right? So okay, let's just keep it this way. Okay, so this is good. Is equal to this, or we only check for this if so if this is false. Why is logic so bad today? It's like an I think I want like an XOR of these two, but then that I don't know how that works with termination. But yeah, I guess just like this. I mean, I knew that I could write it dumbly, but it just looks so dumb. Okay. Um. Okay. Oh, I don't return -1. Oh, of course this is not gonna be. Okay. Let's give it a submit. Yeah, I think I overthought this one a little bit. Because I thought that there were so many cases that this can happen, but honestly, yeah, honestly, I just felt, I don't know. Yeah, I estimated the. I mean, there is still like I consider these a lot of edge cases. It's just that I didn't, I guess, have a clear mental picture of this in my mind. Yeah, okay. I'm just trying to think whether I can optimize this a little bit. I mean, definitely I didn't even use this, so I was just maybe just wasting too much time. I mean, that didn't. I mean, actual programming time, not running time. We can optimize this a little bit, but that's fine. I don't even. I don't know. Like you can make this into a heap or something if you like. But well, no, maybe not. Yeah, it's fine. I don't know. It's not great, but it's fine. What can I optimize? I mean, I can optimize by like keeping track of the lowest thing and start from there. But I think most of the time you don't need to go through all of them. You can just you know sort them or something. But what is that? Greedy swap? Yeah, this makes it n log n though. I'm curious, like what the slower part, out to the middle part. That's the idea that I have, but I worry about a lot of I don't know. I mean, I guess sorting it. I mean, we were talking about sorting it a lot, but and essentially that is what we do, I suppose. What we do now then is just that we greed. Yeah, okay. I mean, we kind of played around that idea here, but I just worried a lot about the edge cases, and I wasn't. I think, like I was saying, lexicographically smallest was the hardest part of the problem, and I think I just kind of. I don't know. I think I overestimated that part a little bit. I think we can actually, because if you once you sort it, and we kind of did a sort. We did a linear, what's it called, bucket sort. But basically the idea here is that we once you see stuff in the middle, you can. Yeah, because lexicographically, as long as this is not the case, I think that's the proof that I was missing until I kind of came up here, and I came up with this. But this is a solution based on the ideas that we had, like building on the other stuff, which is why I had some other funky stuff. But I think if we re-examine the problem in light of okay, there will always be a solution. And I had some ideas about the thing, but all you have to do is just shift some stuff on the second half back. I don't think you ever need to sort the first half because it will always be lexicographically the best. And the second half, by pigeonhole, now that we understand it a little bit more, there will always be space, because unless it is n/2, there will always be space in the second half that matches the space in the first half. So we just have to shift the chunk in the middle. Yeah, shift the chunk in the middle. So we can, with that, we can probably implement something a little bit smarter, which is that, yeah, right? So for C in F dot keys, and we'll sort this one. But keeping in mind that this sort is actually much faster because this is sorting on the size of the alphabet, where they were sorting on the size of the string. Not a big deal because they probably don't care about it, right? So we can maybe do something like I want it to be a thing, but how do I do that? Oh, I guess I can just do. And then now all we have to do is the swap of the second half. And you could do that with 2 pointers. Yeah, you can do it with 2 pointers. So then we have so we say for left is in range of n, starting from n over 2. So now you're in the middle. And then basically, if answer of left is equal to answer of n minus left minus 1, then now we have to go to the right. So then we also have right is equal to n over 2, right? So then while yeah, we want to make sure that right is equal to max of left right. So we keep on incrementing just to make sure. But if not, then while answer of right is equal to answer of left, then right increment by 1. So then now that they're different, then we can swap and then at the end this should be good. Give us submit. All right, there we go. Yeah, so once we have cleared the idea, then yeah, it's pretty straightforward. I actually don't remember what I read, but I guess I did copy from this somewhat, but wasn't thinking about this one actually. I think that triggered something, but I didn't really look at the code. I was just like, oh, because all the observations we already kind of pointed out, but it still takes time, and without a lot of practice, it takes time to kind of put the ideas together. Because then once you put the ideas together, like we did otherwise, you kind of saw the exploration with the longer way, which actually the quote unquote the greedy one character at a time to see with force way. It comes up a lot in a lot of different algorithms, so that's why I kind of gravitated toward that. But I think the part that you saw me revisit was figuring out this part, and this part was not that. This part right here makes. Just to be clear, this part makes sense and pretty straightforward. This part also makes sense, but the hard part isn't what's here in the code. The hard part is actually what is not here, which is the proof that you always had space. And I kind of did some ASCII art here in that, because initially I thought that you have to put stuff in a way such that you want to evenly distribute the max characters from the left and the right chunk. But then the lexicographically smallest part was like, oh wait, you can just shift them apart, and if you have less than and it always retains that matching of the number of the max characters in the first half and the second half, or number of characters not the max characters in the second half, right? There's that invariant, and as a result of that, then you just shift them one at a time, which is what I do here, and which is what this implicitly said, and this solution kind of comes from examining the property of this, because once I was trying to optimize this a little bit, to be honest, because it was like, I forget what it was, but it's just much slower. I was like, okay, can I actually, think, like, what kind of solution does this generate, right? Well, for the first half, this is just literally just sorting, right? Because this never triggers. So I was like, well, I mean, I guess the or part makes it so that it triggers, but the first half. So then I was like, oh, that means we have to do in the second half, and then I had to re-examine why that is true. And I was like, oh, because of this invariant, that is true, and because of this invariant, it allows us to rewrite the code such that we only have to swap them as they fit, as we're able to fit. And this goes by really quickly. I think after, well, yeah, and like we can probably even terminate early after this is true, because after this is false, we don't do anything anymore. And the thing with the sorting, which we kind of do here, and implicitly we did the sorting here without me being explicit about it. It was just me trying to be greedy about the lexicographically smallest. Is that only one number, or sorry, only one character can be in both halves, right? Because, and it doesn't have to be the most frequent character even. Yeah, it does not. So for example, because that was my focus and worry, but you can have like 6A's, 2B's, and like 6C's, but obviously we have to shift to B, right, instead of the A or the C. So yeah, so it doesn't actually have to be the most frequent character. Yeah, and that was basically what this code tells me. And I was like, okay. Well. Anyway, that's a very long explanation. But I think part of it is that I'm trying to figure out what lessons for me myself learn here as well, and kind of explore the problem a little bit. I think this solution is the more general one. I mean, like I said, like even this part is hard. You have to kind of figure out things. Like the proof is the stuff that is not here, right? That makes this enough. That makes this sufficient. And I'm driving, and this part comes easy after you make that observation, but it's hard to make these observations together very quickly in the first time. But yeah, yeah, that's all I have for this one. Let me know what you think. I mean, just to be clear, this is linear time, linear space, kind of. If you want to say alpha is the size of the alphabet, then this is O of alpha log alpha plus n, because yeah, I mean this is linear, this is O of alpha, this is O of alpha log alpha, and this is just me being lazy. You could even optimize this part, right? We don't need this anymore. We can actually just have I mean, this is just easy to write, but you can actually just do like something like that, right? And then this doesn't have to be sorted anymore. Yeah, in fact, even with this, we don't even need to sort that. We would just go through all of 26. It's a little bit, yeah. I mean, what's it? ASCII lowercase. I don't know. I mean, this if you have like only 5 characters, then the sorting is actually faster and stuff like that. But if you want to talk about complexity, then yeah, this is going to be O of alpha instead of alpha log alpha. And I mean, technically, it is not the same alpha, right? Because one of them is input sensitive, which is the number of unique unique alphabets, where this alpha is just the size of the maximum alphabet, right? There are a lot of nuances once you want to get really deep into it, but ultimately it doesn't really matter that much. I'm just being pedantic because this is the internet and this is what we do. Anyway, that's all I have for this one. Let me know what you think. Just to be clear, this is O of alpha plus n for time. And for space, this is O of n space. You can't really do better than that because that's the size of the output. So yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.